Good afternoon, Dr. Sir. My name is Gan Chiu. I am from gruop9. My team member is Wanjawan and Lai Kai Chen. Now I will demo how to run our program. At first, we run this code assignment tree, and this is the output. If we click on the global threshold and choose next, it will direct us to choose an image. We can use the image and enter the global threshold value and enter the width of output and the head of output. It will show the output. If we choose save, it will save in our desktop. If we play reset, it will reset the picture. And next, if we choose the auto threshold, we play next. We also use the image one as example, and we need to enter the width of output and the head of output, and this is the output of auto threshold. As a save, we can save and reset. The last one is the additive. We choose next. Use as image one as example also, and all input the value and the parameter, the width and the height. You can see the result, and that's all. Thank you.
Good morning, doctor. I'm Lai Kai Chen from gruop9. So my part is to present the flow process for the assignment tree threshold thing. So throughout the process of image thresholding, first we will run the program. Then inside the program there will be a menu for the user to choose either to apply the global threshold, absolute threshold, or adaptive threshold. And then after select one of the threshold, then the user will proceed to the next to select the image and display the image selected. Then after that, the image will convert it into the grayscale using the predefined code in the Python. And then if the user choose for global thresholding, then the user will need to enter the global threshold and then the height and also the width. The global threshold value can be any value, but by default, the global threshold value will be 127. Then after enter these three values, then the code will apply the threshold by using the cv2.threshold with the threshold binary, which we'll use to uh, perform the global threshold. After that, the code will convert the threshold image into a color image, and then we're using the bitewise OR operation to restore the original color of the image. Then this will remove the potential noise and make the image look like the original with some removal of things in the background, and then the image will be displayed. So the user can choose to save the image or reset. Then if in this process the user choose to perform the absolute threshold, then there will be some different way. The user only need to enter the width and also height value. After that, the code will apply the thresholding using the threshold values which is set to 0, and then the parameter of cv2.threshold binary, and also using the absolute threshold. After that, the same process of converting into color image, and also use the OR operation to restore the color of image. And then after that, if the user choose for this adaptive threshold, and then the user need to enter the block size parameter and also the width as well as the height. In this adaptive threshold, there is some difference where inside the code they will use the functions to utilize the cv2.threshold binary, and also by using this adaptive threshold Gaussian C, the adaptive threshold can be applied. Then after that, you can use the user-defined block size also for this parameter one, which will be used inside the function. Then after that, you will perform the same way like the previous two threshold method, which will convert the threshold image into color image, and then after that, we will display the result, which has performed the operation of image thresholding. That's all for my part for process flow. Thank you.
Greetings to Doctor. I'm Waijawan and I will be explaining about our program code. Line 8 until 12 are the imports. We import CV2 for image operations, tkinter for graphical user interface, and matplot library.pyplot for plotting the images. Line 14 until 173 are the image thresholding class. The image thresholding class inherits from TK class, which is the tkinter span application window class. The init method is the constructor for the image thresholding class, and it will call manipulation menu to set up the GUI when an instance of the image thresholding class is created. Manipulation menu sets up the main window for the image segmentation application. In manipulation menu method, the title function sets the window's title, geometry function sets the size and position of the window. 500 times 400 plus 50 means the window has a width of 500, height of 400, and it will be shifted 50 on x-axis and 50 on y-axis. Lastly, it will call the setup menu function to set up the body of the window. Setup menu method sets up various widgets such as labels, buttons, and radio buttons for user interaction. In setup menu method, line 31 and 32 creates a label in the body of the window. Then line 34 and 35 is to add a horizontal separator line. Line 38 until 51 is to create the radio button question field to ask the user to choose a segmentation method. The segmentation methods are wrapped in another frame to be displayed in the same line horizontally. We are using loop here to create the radio button selections. Line 53 until 54 is to create the next button to trigger the get manipulation function when the button is clicked. Then, line 59 until 64 is to create the footer frame, which consists the save button and the reset button. Save button will trigger the save function, whereas reset button will activate the reset function. Get manipulation method determines the selected segmentation method and calls the corresponding function. In get manipulation method, it closes any existing matplotlib plot first. Then it calls open image bar to get the image bar for image segmentation. After that, if-else statement is used to check the index of the submitted radio selection. If the index is 0, which is global threshold, it will call askGlobalThreshold function. Else if the index is 1, which is also threshold, it will activate the also threshold function. Else, the selected threshold will be adaptive threshold and triggers askBlockSize function. The open image file method is to open a file dialog to choose an image for manipulation and displays it. The open image file function will firstly open a file dialog to select an image file with file dialog.askOpen file name. The initial directory is set to the images folder in the same folder as the program called store. Then the program reads the selected image using OpenCV_read function. The raw image is used to store the input image. Next, we create a copy of raw image and store it as IMG. The IMG acts as the output after image manipulation. Calling this function also closes any existing OpenCV windows and matplotlib plots. Lastly, it displays the selected image using cv.imshow function. The askGlobalThreshold method purpose is to ask the user for a global threshold value, and it applies global thresholding. sd.askInteger is to prompt the user for a global threshold value. The minimum threshold value is 0, and the maximum value is 255. If the user enters value smaller than 0 or greater than 255, they will be asked to re-enter the threshold value again. If no value is provided, the value defaults to 127. Then it calls global threshold to apply global thresholding. The askBlockSize method asks the user for block size and parameter 1 values for the adaptive thresholding. Firstly, it prompts the user for block size and parameter values. The block size should be odd number. A while loop is used to ask user input on the block size again if the user entered an even number. The values default to 45 for block size and 10 for parameter 1 if no values are provided. Lastly, it calls adaptive function to apply adaptive thresholding. The global threshold method applies global thresholding to the image. cv.destroys all windows and plt closes any existing OpenCV windows and matplotlib plots. cv.convertColor functions converts the image to grayscale. cv.threshold applies thresholding with the user-defined threshold value. We are using cv.thresBinary flag to create binary image as output. After that, we convert the threshold image back to colored. Then we combine the threshold image and the original image using bitwise OR to restore the image original color. Lastly, we pass the raw image and the IMG to display function to show the images. Also threshold applies also thresholding to the image. The steps are almost similar to the global threshold method. The only difference is that it applies also thresholding using cv.threshold with the cv.thresAltSu flag. The adaptive method applies adaptive thresholding to the image. The steps are almost identical to the global threshold and also threshold methods. However, in these methods, we are applying adaptive Gaussian thresholding using cv.adaptive_threshold with cv.adaptive_Gaussian C flag. Let's move on to the display function, which displays the input and output images using matplotlib. First of all, it prompts the user to change the display output window dimensions, namely width and height. The window size defaults to 8x4 if no values are provided. The matplot library is using RGB instead of BGR, so we need to twist the color channels by setting this. Then we set the title of each image and turn off the axis for better view. plt.show is used to show the matplot library plot. The second last method is save. Line 162 is used to get the file type of the input image like JPG, PNG, and so on. Line 163 prompts the user to choose a file name for saving, and line 164 combines the file name with the original file type. Then we use cv.unwrite to write the manipulated image to the specified file. After that, it will close any existing OpenCV windows and matplotlib blocks. Finally, the last method is reset. Reset will close any existing OpenCV windows and matplotlib blocks. 9175 until 177 is the main function of our program. This section creates an instance of the image thresholding class and starts the tkinterm loop, making the application responsive to user interactions. That's all from me. Thank you.